So I'm going to do another example of determining the empirical and molecular formula. So for this one, we're going to have a compound that is 27.87% phosphorus, and the rest of it, 72.13%, is sulfur. And the molar mass is 444, so it's pretty big, 0.56 grams per mole. All right, so same process as in the preceding video. We're going to pretend like we have 100 grams, and then that means we have 27.87 grams of phosphorus, so on for the sulfur. And so you pretend you have 100 grams, convert it to moles, because the formula, after all, is written as a ratio of moles, or a ratio of atoms, just counting atoms, and then figure out how to get the whole numbers from there. And so let's go ahead and do it. So 27.87 grams of phosphorus. And I look up phosphorus, should remember it, 30.97. So it's 30.97 grams of phosphorus for every 1 mole of phosphorus. You do that, 27.87 divided by 30.97. I get, can you see that there? 0.89999. Now I'm going to round that to 0.90 moles of phosphorus. Now, why did it's so close that seems legal, right? Because you got 4 digits there, it's going to round up to 0.90. So I don't know if we haven't talked too much about rounding, but as long as you have 3 digits on WebAssign, and at least 3, you can have more, you won't get docked for rounding. But rounding is really important. So I was going to tell you a little story about rounding. So there's this talking sheepdog. So, oh, lame. So anyway, after this talking sheepdog gets all of the sheep into the pen, he reports back to the farmer, all 40 accounted for. But the farmer answers back, but I only have 36 sheep. The farmer says, I only have 36 sheep. There is 40. I know, says the sheepdog, but I rounded them up. Anyway, so you can round that up because it's so close to 0.90, right? And so let's do the sulfur as well. Sorry for that little diversion. I should put in the YouTube videos like, okay, you can skip until this time. So sulfur weighs, what's sulfur's mass? 32.07. 32.07 grams of sulfur is 1 mole of sulfur. I'll do that. 72.13 divided by 32.07. And I get 2.25. Does that seem like fair rounding? Yeah. 2.25 moles of sulfur. All right. So now when you look at it, we're going to take the smallest one and divide it into the larger one, right? So, you know, you wouldn't have to. After all, it's a ratio of numbers. It's just that most people can handle numbers bigger than 1 better than they can fractions. Your brain can just see it better, right? Because you count with your fingers, not with fractions. And so I think conceptually it's just easier for most people. So I'm going to take that and go 0.90 moles of phosphorus. And when we do that, we'll have the number of moles of sulfur per mole of phosphorus. So let's do that. So I take 2.25 divided by 0.9, and I get 2.5, right? I get 2.5 moles of sulfur per mole of phosphorus. So it's not a whole number for every 1 mole of phosphorus. Now, you can probably pretty quickly see what the empirical formula is going to be from that, but imagine if you had 3 or 4, and maybe if it's a third. Anyway, so If you have trouble seeing it, one thing that you can do is just go ahead and write it down like it's a formula. Phosphorus 1, now we wouldn't put the 1 there, but let's explicitly write it. Phosphorus 1, sulfur 2.5, and then see how can I get these to whole numbers. I can't change the relationship between them. So 2.5, if we multiply it by 2, it will be a whole number. So times 2, it's phosphorus 2, sulfur 5. And that, in fact, then is the empirical formula for that compound. And so it's all, if it's a third, 0.33, then I'm going to multiply by 3, and you have to multiply all of them by the same thing, right, to get to a whole number. And, if it's 0.25, you can figure that out, right? So it's just, how can I get this to be a whole number so that all of them are a relationship of whole numbers? Well, that's the empirical formula. What about the molecular formula? So again, the molar mass is 444. So we know the molecular formula is some multiple of this. It's either P2S5 or it's P4S10, etc., etc. So what we have to do is we have to find the mass of this and divide, see how many times it fits into that molar mass. So I'm going to do that. So 444.56 grams per mole. And I'm going to divide it by the mass of that. So the mass of that's going to be 2 times the phosphorus, so 30.97, plus 5 times the 32.07, right? And I get 222. Look at that. You don't even have to do the math on it. 29 grams per mole. So that's going to be 2. And so that means the molecular formula is P4S10. All right. So hopefully this helps in doing the empirical and molecular formula problems. Thanks.